According to the National Electrical Code, the correct conductor size for the stated application is number 3THHN/THWN. Using the National Electrical Code Table 310.15b16, the ampacity of number 3THHN/THWN in a 1 and 1/2 inch conduit is 125 amps. The National Electrical Code also requires conductors to be sized for a voltage drop of not more than 3%. Using the National Electrical Code Table 310.16, the voltage drop for number 3THHN/THWN over 40 feet at 125 amps is approximately 2.2%. Therefore, number 3THHN/THWN meets both the ampacity and voltage drop requirements for the subpanel feeder. The process of selecting the appropriate conductor size for a subpanel involves several crucial steps, ensuring safety and compliance with the electrical codes. Firstly, it's essential to determine the load requirements of the subpanel. This involves calculating the total amperage that the subpanel will need to supply to all its connected circuits and devices. Once the load requirements are established, the next step is to consult the National Electrical Code, specifically Table 310.15b16 or its equivalent in your local electrical code. This table provides the ampacity ratings of various conductors based on their size, insulation type, and installation method. Ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. It's crucial to select a conductor with an ampacity rating that is equal to or greater than the calculated load requirements of the subpanel. However, ampacity is not the only factor to consider. Voltage drop, which is the decrease in voltage along the length of a conductor, must also be taken into account. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even malfunction. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and feeders. Feeders are the conductors that supply power from the main service panel to the subpanel. To calculate voltage drop, you need to know the length of the conductor, the amperage it will be carrying, and the conductor's resistance. The resistance of a conductor depends on its material, size, and temperature. Voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance volts equals amps x ohms. Alternatively, you can use voltage drop calculators or tables provided in the National Electrical Code or other electrical resources. If the calculated voltage drop exceeds the recommended 3%, you will need to increase the size of the conductor to reduce its resistance and lower the voltage drop. In the example provided, number 3THHN/THWN conductors were selected for a 125 amp subpanel feeder with a distance of 40 feet. This selection was based on the fact that number 3THHN/THWN has an ampacity of 125 amps, which meets the load requirements of the subpanel. Additionally, the voltage drop for number 3THHN/THWN over 40 feet at 125 amps was calculated to be approximately 2.2%, which is well within the recommended 3% limit. It's important to note that the specific requirements for conductor sizing may vary depending on local electrical codes and regulations. Always consult with a qualified electrician or electrical inspector to ensure that your installation complies with all applicable codes and standards. In addition to conductor size, other factors to consider when installing a subpanel include the type of conduit used to protect the conductors, the size of the grounding conductor, and the proper bonding of the subpanel enclosure. Conduit protects the conductors from physical damage and environmental factors. The size of the grounding conductor must be adequate to safely carry fault current back to the main service panel. Bonding ensures that all metal parts of the electrical system are electrically connected, providing a path for fault current to flow and trip the circuit breaker. When working with electricity, safety is paramount. Always energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Remember, this information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for proper installation and adherence to all applicable codes and regulations. The calculations provided are for informational purposes only and do not account for all factors that may affect conductor sizing. Conductor sizing is a critical aspect of electrical installations, ensuring safety and optimal performance of electrical systems. Understanding the principles behind conductor sizing, including ampacity, voltage drop, and National Electrical Code requirements, is essential for anyone working with electricity. Firstly, ampacity is the current carrying capacity of a conductor, and is determined by the conductor's size, material, insulation type, and ambient temperature. The National Electrical Code provides tables that list the ampacity of various conductors under different conditions. When selecting a conductor, its ampacity must be equal to or greater than the maximum current that the circuit will carry. Secondly, voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, lights to dim, and motors to overheat. The National Electrical Code recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the conductor's length, current, and resistance. Voltage drop can be minimized by using larger conductors or shortening the circuit length. Thirdly, the National Electrical Code provides comprehensive guidelines for conductor sizing and installation. The National Electrical Code covers various aspects of conductor sizing, including ampacity, voltage drop, insulation type, and installation method. It's essential to follow the National Electrical Code to ensure a safe and code-compliant electrical installation. In addition to these fundamental principles, several other factors can influence conductor sizing. These factors include the ambient temperature, the number of conductors in a raceway, and the type of load being served. High ambient temperatures can reduce the ampacity of conductors, so it's necessary to adjust the conductor size accordingly. When multiple conductors are installed in a raceway, their ampacity must be derated to prevent overheating. The type of load being served, such as lighting, motors, or heating equipment, can also affect conductor sizing. Motors, for example, require larger conductors to handle their inrush current during startup. The process of conductor sizing typically involves the following steps. 1. Determine the load requirements of the circuit. This involves calculating the total current that the circuit will carry. 2. Select a conductor with an ampacity equal to or greater than the load requirements. 3. Calculate the voltage drop for the selected conductor. 4. If the voltage drop exceeds the National Electrical Code limits, increase the conductor size or shorten the circuit length. 5. Ensure that the conductor's insulation type and installation method comply with the National Electrical Code requirements. 6. Consider any other factors that may affect conductor sizing, such as ambient temperature and the number of conductors in a raceway. 7. Document all calculations and conductor selections for future reference. Conductor sizing is a critical aspect of electrical installations, and it's essential to follow the National Electrical Code and best practices to ensure a safe and reliable electrical system. Always consult with a qualified electrician if you have any questions or concerns about conductor sizing. Additionally, consider the environmental conditions in which the conductors will be installed. For example, if the conductors will be exposed to direct sunlight or high temperatures, you may need to use conductors with a higher temperature rating. Also, if the conductors will be installed in a corrosive environment, you may need to use conductors with a special coating to protect them from corrosion. When selecting conductors, it's also important to consider the type of terminals and connectors that will be used. The terminals and connectors must be compatible with the conductor size and material. Using incompatible terminals and connectors can lead to loose connections, overheating, and even fires. Furthermore, proper installation techniques are essential for ensuring the safety and reliability of electrical conductors. Conductors should be properly supported and protected from physical damage. Connections should be tight and secure. Insulation should be intact and free from damage. By following these guidelines, you can help ensure a safe and reliable electrical installation. Remember, electrical work can be dangerous, so it's always best to consult with a qualified electrician if you're not comfortable working with electricity. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. The National Electrical Code is updated every 3 years, so it's important to stay up to date on the latest requirements. The National Electrical Code is available from the National Fire Protection Association and other sources. In addition to the National Electrical Code, many local jurisdictions have their own electrical codes. These local codes may be more stringent than the National Electrical Code, so it's important to comply with both the National Electrical Code and local codes. Electrical inspections are typically required for new electrical installations and for major renovations. Electrical inspectors will check to ensure that the installation complies with the National Electrical Code and local codes. Passing an electrical inspection is essential for obtaining a certificate of occupancy. Conductor sizing is a complex topic, and it's important to have a thorough understanding of the National Electrical Code and electrical principles to ensure a safe and code-compliant installation. If you're not sure about something, it's always best to consult with a qualified electrician. They will be able to assess your specific needs and recommend the appropriate conductor size for your application. Proper conductor sizing is essential for preventing electrical hazards and ensuring the reliable operation of electrical equipment. By following the National Electrical Code and best practices, you can help create a safe and efficient electrical system. It's also essential to consider future load growth when sizing conductors. If you anticipate that your electrical needs will increase in the future, it's a good idea to install larger conductors than are currently required. This will save you the cost and hassle of having to upgrade your electrical system later on. When selecting conductors, it's also important to consider the voltage rating of the conductors. The voltage rating of the conductors must be equal to or greater than the voltage of the circuit. Using conductors with an insufficient voltage rating can lead to insulation breakdown and electrical hazards. Moreover, when installing conductors in a conduit, it's important to follow the National Electrical Code guidelines for conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. The National Electrical Code limits the conduit fill to prevent overheating and to make it easier to pull conductors through the conduit. Additionally, it's crucial to use the correct tools and equipment when working with electrical conductors. This includes wire strippers, crimpers, and multimeters. Using the wrong tools can damage the conductors and create electrical hazards. It is also important to properly label all electrical conductors and circuits. This will make it easier to identify and troubleshoot problems in the future. Labels should be clear, durable, and easy to read. When working with electricity, it's always best to err on the side of caution. If you are not sure about something, don't hesitate to ask for help from a qualified electrician. Electricity is a powerful force, and it's important to treat it with respect. In conclusion, conductor sizing is a critical aspect of electrical installations that requires careful consideration of various factors, including ampacity, voltage drop, National Electrical Code requirements, environmental conditions, terminal compatibility, installation techniques, and future load growth. By following the National Electrical Code and best practices, you can ensure a safe, reliable, and efficient electrical system that meets your current and future needs. Always consult with a qualified electrician if you have any questions or concerns about conductor sizing or any other electrical work. Remember that safety should always be your top priority when working with electricity. Take the time to learn about electrical safety practices and follow them diligently. By doing so, you can protect yourself and others from electrical hazards. And regularly inspect your electrical system for any signs of damage or wear. If you notice any problems, have them repaired promptly by a qualified electrician. Proactive maintenance can help prevent electrical problems from becoming serious. Always remember to disconnect power before performing any electrical work, and use appropriate personal protective equipment, such as gloves and eye protection. By following these simple safety precautions, you can greatly reduce your risk of electrical injury. Electricity is an essential part of modern life, but it can also be dangerous if it's not handled properly. Take the time to learn about electrical safety and follow the guidelines in the National Electrical Code. By doing so, you can help ensure a safe and reliable electrical system for yourself and your community.